By now you have noticed that the first section of our Measurement and Scientific Inquiry seminar is entitled Black Box Number 1. And hopefully you've been asking yourself the question, why is that? What exactly is a black box? A black box is an analogy for a scientific phenomenon. It is something that we are able to observe, just like a scientific phenomenon is, and it is something that we are trying to explain, just like we do with a scientific phenomenon. Our goal is to be able to figure out how does it work. Now, in this case, the black box that we're going to be referring to is a virtual box. It's a box that has a circular hole on the top and rectangular uh, openings on the side. What we're going to be doing is we're going to be dropping some virtual marbles into our virtual black box. We call it a black box because we don't know what's on the inside. All we're able to do is observe, just as we are required to do as scientists. We're going to see what happens, and we're going to try to explain why it happens the way it does. So for the next minute or so, all you're going to do is observe. You want to look at the black box, you want to look at what's happening, and you want to do so in such a way that you can agree in terms of what you see with other people. So here's our black box. So now that you've had a chance to observe black box number 1 and how it operates, now it's time to think like a scientist. Now, scientific thinking when it comes to observation is very similar to mathematical thinking. In mathematics, what we want to do is we want to look for patterns. Mathematicians observe how things work and they try to explain things by identifying patterns. And that's exactly what you need to do right now. You need to think about, what did I observe? If you have to, you need to go back and observe the phenomenon again. Rewind the video, look at what happened. And after you, as you're observing, you have to be thinking, would everybody agree with my description of what happens? Because remember, an observation needs to be something that we see that everybody can agree on. And then we have to think of it in terms of breaking our observations down into qualitative or quantitative. Can we assign numbers to our observation, or is it simply something that we are seeing with our senses? And after we've made our observations, we have to remember that scientists try to describe or explain what made it happen that way. That's what scientists do. Not only do they observe the patterns, they try to come up with an explanation of what made it happen that way, or how does it work. So your goal is simply this. You've made your observations. You need to create a model to explain what you saw. Your goal is to create a valid scientific model to explain your observations. Remember, a valid model must explain the observations that you saw that everybody can agree upon. It must be realistic in nature. It can't violate any rules or be somehow supernatural or magical. And finally, you must be able to take your model and use it to predict what will happen next. If you can do those things, if your model can stand up to these criteria, then it would be considered a valid scientific model. So we're going to think like a scientist, and everybody in their groups is going to come up with what an explanation of how they think the black box works. And then we're going to share and we're going to try to figure out um, who came up with the best, most valid scientific model. So good luck, and we all look forward to seeing all of your presentations.